Hello. Okay. Good morning. So today we're gonna continue with the Python basics about lists and conditional statements. Again, make sure you practice. I just posted lab 4, and you can find it on Canvas, but you can also find it on our Google site. So I'm gonna quickly go through the instructions. So we go to the instructions here. If you open it, and so there are a couple of steps that you need to do. First is to download the assignment. So if you click the link, it should take you to the web page, and so you want to download this one to your computer, and then you can start working on that using a Visual Studio Code or Jupyter Lab. Okay. And once you are done with that, make sure they restart the kernel. Also, you need to have a base in here. So what I'm asking for at the end is that I want you to submit a link like this. So if I open this link, for example, the notebook should be hosted on your GitHub repository, wherever you want, but it needs to be on GitHub. And you also need to have the open in collab base, just like what we did in the previous lab assignments. So if I click this one, then it should open in Google Colab, so that if I need to run that through, I can do it. But before you submit the link, make sure that you, for example, after you finish all the your stuff, make sure you rerun runtime and run all again, or restart the kernel and run all again. Okay, so if you're doing it on Visual Studio Code or in Jupyter Lab, make sure you run it again, because I need to see everything works from the beginning to the end. And also, don't delete the first code block. This one is just to tell me when did you actually submit the assignment. Okay, so again, follow the steps. Download the notebooks, do it, finish it, restart the kernel, run all again, submit. That's it. Okay, I just need the link, and it needs to have a base so that I can test it if I want to. Questions? So this lab has 20 questions. They're pretty like simple, basic Python questions. If you have any issues, let me know. You're also welcome to Google. Okay, this course is not about, so I'm trying to force you to learn something. It's more about how much you want to learn, but these are the bare minimum that you need to meet. So you need to understand like the basics, otherwise you will have difficulty later trying to implement something to your Python package. And it should not be too difficult, but I want to provide enough exercises for you to practice so that you can get to know Python a little bit better, rather than we go directly into Geospatial. Any other questions? If not, let's continue with what we cover in the last lecture. So let me open Visual Studio Code. Last time we already covered the variables and lists, data types. So today we're gonna do a little bit more about looping through the list, and this is very important. All the programming languages have some kind of looping mechanism, and Python is actually very easy to use. And we're gonna go through the examples today about lists and also conditional statements, and those are pretty much you will see everywhere in the coding examples you're gonna find online, because they're so commonly used. So let me open the notebooks. Okay. Again, if you have any questions, stop me, ask questions, and whoops. I hope it works. Sometimes it takes a while. If it doesn't work, then I can use Jupyter Lab. Just as a backup. Okay, it opens now. Great. So last lecture we did talk about list, right? So this is defined by square brackets. Okay, remember? So Python has different meaning for different characters. So square brackets means a list, parentheses means a tuple, and curly brackets means a dictionary. We're going to cover dictionaries and tuples later, But for list, square brackets, and then separate by comma. Within there, you can have a collections items, and the items do not have to be the same data type. It can be a nested structure, okay? So we're going to also go through how to have a nested list in there. And right now, the first example is pretty simple, right? We have different cars models, right? So if you're trying to, in this case, trying to loop through the list and then trying to base on the conditions. So this one here, actually have the looping and also the conditional statements. So first, we define the list, and then this is where you can do the looping in Python. So for something in something, okay? So in something, that means you're going to have a collection. So that one is a list. It doesn't have to be this. It can be a dictionary. It can be anything, as long as you have a collection of something. This is pretty intelligent, so we can figure out basically your looping through. For example, for let's say right now I have a list of all your names in this class, and I can say for student in students, and then if your name is blah blah blah, or if your gender is male or female, I can have different conditions and it can do something differently. So this is where you can do in here. And keep in mind here, this variable name doesn't really matter. It can be any name. It doesn't have to exist because that's just a temporary variable, okay? So I can say for A in class, for B in class, it doesn't really matter. So that one is just a temporary variable when you're looping through the code. So if I run this one, take a look, right? Oops, I need to select the kernel, and let me select this one, run. Just still running. Yeah, it might take some time. So again, this is when you are doing the looping, right? For car in cars, and make sure you also put a colon at the end. So in Python, the colon means you have this coding block is not finished yet. It's going to go to the next line, and you need to be indenting, okay? So if your code looks like this, it won't work. You probably see the error message in here. If you have a colon, the next line must be indented. If it doesn't find it, that means it's incomplete. So what we're trying to do here is like, okay, I'm going to go through all of you. If your name start, like the initial start with M, I'm going to give you like 10 credits, okay? If you start with something else, no credits, right? So this will be something that you can do in here easily, right? And I can also say, okay, for students in students, if your major is geography, okay, you do extra work for this class. If your major is non-geography, you do less work, okay? So I can, basically you can do through all kind of things and then to do different actions based on the condition. Understand? So here, this variable must already exist. This one you don't have to, okay? So this one I can just say for A, but you need to have OA in here. And this is also a conditional statement. So in Python, it's two double equal. So conditional statements is, if it's equal, that means it's double equal. If it's just one equal sign, that means you are doing assignment. You're doing assign value to something. In this case, we're not. We're trying to compare. If you're doing comparison, you'll be two equal, like means equal. Non-equal, greater than, less than, greater, equal than, less or equal than, something like that. So how about this? For those you probably know, like non-equal. What's the sign for non-equal in Python? Equal what?
Equal slash.
Equals this one? Python people? Exclamation. So yeah, you're right. Exclamation equal. This is called non-equal. So Python is a little bit different from other language. I forgot like R, how R people like, for those who are using R, what's non-equal in R? The same? Okay, good. So exclamation. Oh, I have double exclamation here. Right. So this is called non-equal. Right now, if I run again, you should expect, right? If this not equal to BMW, then you do this, and then if it is equal to BMW, then it's going to do the other one. So in Python, it's actually looping through the conditional. You can have multiple if and else. We're going to talk about later, but this is the most simple looping and conditional statements in Python. You can certainly use less or equal than if it is a number or something like that. For example, if you say, I would say that, okay, if you start at UT less 2 years ago, blah blah blah, you are right now a senior or junior, right? If you just started, you are freshman, something like that. So you can have conditions just to figure out what is happening, and in between, this can do all kinds of lines. It doesn't have to be just one line. You can do multiple lines. You can have a lot of conditions in here. So the for loop is a call block. If and else is also a call block. So you also need to indent. So keep in mind here, indentation in Python is very important. So it's very sensitive, and make sure that you understand and just practice. You will get better when you practice more. Okay. So this is about the for loops and conditional test, just like this one here. These two has totally different meaning. So the first one is just assign a statement, assign a value to something. The second one is check whether they're equal or not. So looks very similar, but they have very different meaning. So here, where does this two come out? So in Python has like Boolean. This is called Boolean data type. So Boolean results, either true or false. Okay. So right now, I would say, I'm not sure if we can do this. Result equal to. Okay, it works. So what does this one really mean here? Can someone tell me, explain to me what does this line mean? The first line should be easy, right? What does the first line doing? What is this, the first line? Yeah, creating a variable, you assign a variable to this one. How about the second one? What does this mean? Assign false to result. Yeah, so that's what I meant previously. Python read from the right to the left. It doesn't execute from the left to the right. So what it's actually doing is here, we create a variable equal to BMW, and then we check whether the this variable equal to BMW or not. So if it is equal, that means it's true, otherwise false. And that result is going to assign to this one. So right now, what's the result? True. So if you run this one, it should give you like true. Right, so we type like SELULT, right? It's true. Okay. I can also do this here. True equal to true, is it true or false? Is the result equal to true? Yes? Alright. You can do this one. You can also, I think you can also use is. Lowercase is. Yeah. So you can use at least equal. Is means like kind of like this, equal, but the result needs to be exactly the same in order to that. So in Python, this is how you can check whether something is equal or not. So right now, if I change this one maybe to BMW, what's the result? What's the value of the result? False, right? This uppercase. So Python is case sensitive. If this uppercase, this one car is not equal to lowercase BMW, so it's false. False is going to assign to the result variable. It's going to be false. And right now, if I check this one, is result is true? Yes or no? True or false? False. Okay. Understand? So conditional statements are always going to be true or false. There's only two outcomes. There's no like maybe. No, it doesn't work that way. So it is true or it will be false. So that's the two outcomes in here. And again, like if you try to do this one, car equal to something. Also remember here, so the first one is just assign creating a variable. The second one is the conditional statements. Check whether they're equal or not. And how about this one? What's the result? If I execute this one, true or false? right? Audi is Audi the lower, right? It's all lowercase. Is all lowercase equal to this one? Yes or no? True. Okay. Keep in mind, when you apply something, it doesn't have to be all on the left. I can do it on the right. So how about this? Is it true or false? False, right? Because the lower is going to be lower, and the lower you upper again, it's going to be false. I mean, this is just a demo. There's no point of doing things like this. Usually you only check like one side. You do something to one side and then compare it to some result. So this is how you can do that. And as I mentioned earlier, if this non-equal, that means it's going to be exclamation equal. That means, okay, I requested topping this variable equal to mushroom, and if it doesn't equal to this one, I'm going to print out something. So if you execute, it's going to show you, okay, hold on to this one, blah, blah, blah. And for conditional statements, you can compare pretty much anything, okay? You can compare a number, you can compare a string, you can compare an object, you can compare a list. There are all kinds of things you can compare. So in the memory, it's going to figure out whether the content are the same or not. Sometimes you are comparing just the value. Sometimes you're comparing so-called the reference. So essentially you can compare anything pretty much, whether it's equal or not. Okay, so here do the same thing, right? A variable equal to 18, and then we're going to check whether they equal to 18 or not. Of course it's yes, right? How about this one? Answer equal to 17. If your answer not equal to 12, I'm going to print out, right? So if you run, it's going to print out. Equal sign, again, equal sign is assigning a statement, assign a value to something, so it's not a conditional statement. Less than, greater than, less or equal than, greater, equal than, non-equal. So we basically have 6 types, okay? And this is how you do the comparison. So if you assign a variable to 19, is it less than 21? True or false? True, right? And is it less or equal than 21? True, right? Is it greater than 21? False. Okay. So true or false is a variable. So that one is a Python resolve keyword. I can actually do this. I can say, okay, result equal to true. You can do it. You can assign a variable to like this. So I'm gonna say result is true. True or false? Right? True is true, right? This is going to be true. Okay. So this is how you can compare different things. You can also just equal. So as I mentioned earlier, double equal is going to be true as well. So this is how you can check. And besides one condition, now you can have multiple conditions. So this one here, right? We have 2 variables, and you can have something greater, equal, and whatever, and then you have an n. N means you need to meet both conditions. So for example, in the real world, I can say, okay, if your major is geography, and also if your GPA is greater than 3.8, you are a top student, okay? And I'm going to give you a scholarship. Or I say if your major is geography, and also if your, for example, your household income is beneath a certain threshold, I'm also going to give you another type of scholarship, right? So in that case, you have to meet multiple conditions. In Python, the keyword is basically n, right? N. So you can have as many conditions as you like. It doesn't have to be just one. So here, take a look at this one. Age 0, 22, and then 18. The first part here, age 0 greater than 21. Is it true or false? Is the first part true or false? True, right? Because it's 22 greater than 21, right? The second one, 18 is 18 greater than 20, greater equal than 20, 21? False, right? So in order to be true, you need to have all true. If there's n, that means you need to meet all the conditions. Otherwise, the result will be true. So, and pay attention. This is kind of important because Python, when it's executing the code, if you have n conditions, if the first one doesn't meet, for example here, it doesn't check the next one. Understand? Because there's no point. Because if you don't meet the condition, you are out. Understand? So if I, for example here, I've changed this one to, how about this? I changed to 20. The result is going to be the same, right? It's still going to be false because 20 is not greater than 21. But the problem is that the previous one, it executes all the lines because the first one is true, it's going to find until you find another false, and then it stops. But in this case, on Python execute this one, it stops. It doesn't check others. Make sense? So here, if I change this one, let me see if it works or not. Alright, let me run this one. I'm not sure if it can. You see, it works. Why doesn't Python throw an error? Does this variable exist? Right, if you see the curly lines down there, it's not good. Okay, that means something is wrong. So I can create another cell. If I say here, I'm trying to print this one out. Oh, name is not defined. But why you can run this code without any problem, right? So that's what I meant earlier. Because you have multiple conditions. If you have n, whenever it first meets the false, then it stops. It doesn't check all the remaining. So if you have something wrong in there, Python will not know. So this is very important for you to understand. But if I change to all, that click on this one here, it's going to change the outcome. Can you run this one? All means like I just need to meet one condition. So n means you need to find the first false. All means you need to find the first true. Once you find the first true, you are good to go, right? So here, look at this one. Just think about for a moment, right? A0 is 20. Is it 20? Is it greater than 21? True or false? Is 20 greater or equal than 21? False. Can you stop now? No, because it's all. All means you need to find the first true. So it's going to continue to find this one. Oops, the variable doesn't exist. You're going to throw the error. So now you understand like the meaning of n and true. Like when Python is executing, it's going to check the variable, check the numbers, and either find the first true or find the first false. So keep it in mind. Very important. And so this one. Right, n, because 21, 22 greater equal than 21 is true, but it doesn't guarantee it's going to be true because in all the conditions need to be true in order to be true. Okay, so this one here is false, then it's going to be false. Okay. Also, when you have multiple conditions, right now we only have two, so you don't really have to have the parentheses, but when you have like complicated stuff, you might need to have like multiple conditions. So in that way, you can put the parentheses to make sure Python is executing because there's different priority. And sometimes it gets quite confusing. So here, for example, if I do this one, maybe let me have another one here. Say H0 and then H1 equal to 18, H2 equal to 19. Okay, so let's take a look in here, and then n and o I would say is 0, 1, 2. Okay, so now in your mind, try to imagine that what's the result of this one, how Python is actually interpreting the result. So look at the first one here. A0 greater than 21, true or false? True. How about the second one? True or false? Is it 18 greater than 21? False. True and false. It's false. Do I need to execute this one? So this portion is probably not executed, but how about this? Does that change the result? Maybe let me change this one here, just to be, so that you get different results. What about this one? Is the first part true or false? True. How about the second one? So true, right? A is greater than 21? No, right? But the second one is true, right? Is 19 greater than 18, so it's true. True and true, you're going to get true. So now you see, right? I put in parentheses, it changed the totally changed the outcome. So this is very important, especially if you have multiple conditions. Make sure you tell Python explicitly which part going to composite, because otherwise it's going to read from the left to the right when it's checking all the conditions. So it might not be the result that you are expecting. And make sure that when you design the conditions in a way that Python can execute the sequence like what you want it to be. So whether you had a parenthesis or not, sometimes we're going to change the outcome. So make sure that you pay attention to that. And multiple conditions and or, again, if you have or, means you only need to meet one conditions, then you are good to go. Next one, when you are looping through the list, also you can use for some. Earlier we used for something in something, and you can do the looping. But you can also, if you don't use a for loop, if you just want to check something is in that list or not, you can just use the in keyword. So take a look at this one, right? This is a pizza toppings. We have 3 toppings in here, and we're going to check whether this one is in here or not. Also pay attention, right? You need to have something like a string, not a variable. You can also do a variable if you like. So here, if I run this one, right, it's going to be true because it can be found there. But if I change to something else, true or false? Apparently it's not, right? It's not there. But I can also do this way. I can maybe like A equals to, how about this? And then I can say A equal to this one. True or false? This one is in here, so of course it's going to be true. So you can have a variable, you can have a string, I can have a number, you can have anything pretty much. I can also say like 1, 2, 3, 4, 5 in there. True or false? True or false for this one? Yes? No? So not take too long, right? The item is not there, so you're not going to find it. So in means whether you're in there or not. So for example, right now I'm going to check the attendance. Okay, I'm going to loop through all your names in class. I'm going to say, oh, are you in class today? Yes, true, false, right? You can do all kinds of stuff. You can use this to check the condition and check whether something is in a list or not. So list is super important in Python. So if it's not, right, something in something or not in something. So in and not, they are all the reserved keywords in Python. So not in means you are not there. Just like not equal, right? Exclamation not equal. But if you're trying to check something, a list in an item in a list or not, it's going to be not in or in something in something, something not in something. Okay. So this is another one here, right? You have bank users, and then if the username equal to this one, if it is not in there, I'm going to post something. So this can be used in pretty much all the websites, for example, logins, right? So if you're trying to, for example, log into your UTK using a net ID, if you accidentally have a typo, it's going to show you, okay, the user cannot be found in our database. Or it's going to check your password, and it's going to compare password to your password in the database. If it is not equal, it's going to say your password is incorrect, right? So those are all the logics that you will find in pretty much all the website databases. This is how you do the comparison, how you check the conditions. So here, right, we have a list of bank users and the new users, and if it's not in there, you say, okay, you can say something. Just like on YouTube or on Twitter or on Facebook, right? You block somebody, and then when somebody is going to send a message, Facebook is going to check if that user in your block list. If they yes, they can block the message. Otherwise, they're going to send a message to you. Make sense? Or the text message, right? If you block somebody, then it's going to do that. Or you can like, okay, you flag this one as a spam email. Next time when somebody is going to use the email just to send you, Gmail is going to tell that check whether the address is in your blacklist or not. If it is black, it's going to filter out. So this is used in very common in a lot of real world applications. How you check somebody is in there or not, something is in the list or not. And we already covered this one. So in Python, Boolean expressions only have two outcomes: true or false, yes or no. Okay, there's no like maybe. There's no in between. You need to have this in order for the program to know what to execute, right? So if you have a is equal to 19, it's greater than 18, you're going to print out, okay, you're old enough to vote, okay? And if I change this one to 16, what's going to be printed out here? Nothing, right? Because when it's checking this condition, it doesn't meet the condition, and then done, I'm done. It's not going to print out this one, okay? How about this? What's this one? Is it going to print out something? If I ask you, what are you going to see? Okay, it print out. So what's the logic? So keep in mind, indentation, so the conditional statements. If they indented, it belongs to this one. Once it's unindented to the outside, it's going to execute line by line. So you need to pay attention like what this one is actually executing. So here, I'm going to check this one is greater than 18, no. And it's not going to execute anything indented within the next level. So I'm going to skip this one, and it's come up here, and then you're going to execute this one. Okay, so if I put this one here, what do you think? If I execute again, I'm going to see anything? Will you see anything? Yes or no? No, right? Because it indented. It doesn't matter how many empty lines you have in there. It doesn't matter. It belongs to the same code block. So I can have this. Oh, looks like it's like lots of empty lines, but don't get confused. It still belongs to the same code block unless you unindent. So if you unindent, you need shift tab. It's going to move it out, or just hit tab. Can you do this? Of course, Visual Studio Code tell you that something's wrong in here. So you need like this, and if I execute, nothing is going to happen. So if I change this one to like 19, it's going to do this. You see all the empty lines are actually being skipped. So this doesn't, in Python, the line empty line doesn't matter. It's not counted. But sometimes you can have empty lines just to make it more readable if you want to. Okay, so this is how you can make sure that understand what this one is doing, where the line starts, whether it is indented or not. It's going to have different outcomes based on your input. So in this case, how many lines you're going to see printed out? Is 19? Is it greater than 18? Yes. And then it's going to print out these two. Next one, if else conditions. So Okay, why we are skipping? Oh, I think we use this one. We go back to the list slicing later, but supposed to cover the list first. I think I opened the wrong notebook. Anyway, it doesn't really matter. So it's the same stuff. So here you can have if and else, right? So if, else, so if something equal to something, and so here if you have if and else, it's going to check all the conditions until you find one. Otherwise, it's going to be just else. So you can have if, else if, and then the last one will be else. But this is optional, so you don't necessarily have to have like else. You can have just one condition. If it meet this condition, it's going to print out the result. Otherwise, it's going to skip. So here is s equal to 17. Is it greater than 18? True or yes or no? No. Then it's going to go to the next one. So it's going to else, and it's just going to print out. So look at this one here, right? So if I have like 19, is 19 equal or greater than 18? Yes. You're gonna print out this one, and it's gonna skip. So this will not be executed in here. Let me see if I can do a debugging here. If I press this one here, and I forgot what did run, start debugging, and yeah, I've already used here GOS. I think it's better to debug in a Python script. This one is using a notebook, so I have not done this one. Start debugging. Okay, so I think it's still running. So now if I pay attention to here, right, it stops in this line. So right now Python is trying to execute. So if you see my mouse in here, step into, okay, let me show you this way. Test.py. Yeah, it's better to just use a Python script. I think this one might not work well, but let me show you like behind the scene how this is being tested. So this is so-called debugging. If you have a long script and sometimes trying to figure like why this is happening, why this is not happening the other way, you can actually loop through the code, so you can actually figure out how Python is executing. So here it's very, especially for conditional statements and others, or looping, this will tell you exactly which line is being executed, which lines are not. So here, let me Control S. So I create a Python script, and then I can start doing the debugging. So you can either press F5, or you can just go to the one and then start debugging. Oh, you need to put so-called breakpoints. So here, if you on your left side here, you just press your mouse, it's going to add a red dot. A red dot means this is so-called a breakpoint. Breakpoint means when Python is executing, when it meets a breakpoint, it's going to stop. And then you can choose whether you're going to run from beginning to the end, or you're going to stop somewhere. So here I can put it anywhere. So you can have multiple breakpoints. So the breakpoint means you're trying to debug. You want the program to stop there. Otherwise, if you don't do this, right? Keep it here. If you just click like run, start debugging, it's just going to run this whole script, and you might be able to see the result. You see here, lower right corner here, it just shows you the result. But it doesn't stop. The reason that we want to do the debugging is we want to see how Python is executing the code. So here, I can put a breakpoint here, in the second line, and now I can do like run, start debugging. So pay attention here, Python is not going to execute all of them. So now it's better, right? It stops here. So s equal to 19, and then it's going to check this condition. So if s greater or equal than 18, is it true or false? True, right? True, that means it's going to go to the next line. So pay attention here, right? If I press this one, step into, means it's going to go into the code block. So see here, okay? See the line is moving to the next block, right? And then when you move to the next one, it's not executed yet. Until you press this one again, it's going to execute that line. Okay, so now I press this one. Also pay attention to the bottom here. Nothing has printed out yet. So that line, we're just waiting to execute this line. So now if I press this one, okay, you see, you are all enough to vote. And then you move to the next line. It's still there, waiting to execute it. So if I press again, you see, the program stops. It's done. It prints out these two lines, and then it's over. Right? Is this code block being executed? No, it doesn't do that. So right now, if I change this one to here, 17, and let's do the debugging again. You will see the difference is how Python is using figure out the condition. So again here, right now 17 is 17 greater than or equal than 18? No. So now if I press this step into, see where Python is going. You see? It's skipping, it's go to the else condition, and then it directly put into this one. Again, it's not executed yet, so you don't see the result here at the bottom, but once I press this one, and another one, done. Okay, so here, if I have another line here, print, okay, I'm done, okay, with the if statements. So again, pay attention. Depends on how complicated your program is, you will know exactly how it's being executed. So again, I'm going to run this one again, start debugging. H17, and you check the statement, it's false. Okay, it's going to the else statements. And then next one. So see where it's going to come out. Right now we're within the else code blocks, but because there's something else in the script, it's going to get out of the code block and then come to here. So now if I execute, see here, then come to this line, done. Okay, so you're going to see 3 lines printed. So make sure that you know like how to debug your code. This is very important, especially if you're writing complicated scripts. Right now I don't have to. When I read the code, I understand in my mind what the output will look like, but when you get more complicated stuff, you will have to use this debugging somehow. We cover more later next week, but for now you can see this is how you can use. Pretty simple. Just create a Python script and then have your mouse somewhere and to create a breakpoint, and then just run, start debugging. It will stop there. Then you can just so-called step into, so step by step. Otherwise Python is going to run like all the code all at once, and you never know like if there's something wrong or if there's anything you need to fix. So also you can have if else, right? So you can have multiple conditions. So here, they say you are trying to buy the ticket. Depends on your age, right? If it's lower than 4 years old, it's going to be free. If less than 18, 25. If it is like less than 24, 65, it's like 40, price equal to 40, and then 20, whatever, right? So this is how you can actually design multiple conditions. And one thing that Python beginners always, not always, mostly we run into this issue and then make some unnecessary modifications is like in here when you have multiple conditions. So here, like if something less than 4, the price is going to be 0, and if the less than 18, you don't need double conditions. Okay, so in here you don't need to say like if it is greater than 4 and then less than 18. It's unnecessary, because if the first condition is like less than 4, if you go to the next condition, that means it's greater than 4. So in the assignments, try not to do this. So I'm going to show you the wrong way you want doing. It will come up, okay, every year when students submit assignment or in the exam or whatever, they're going to do it like this. So if else if is greater or equal than 4, and you're going to write something like this, or sometimes you will like is greater equal than 4 or something, and Sometimes you're going to write something like this. Okay, so pay attention. Unnecessary, you don't need to, because if the first condition doesn't meet, automatically the remaining conditions will be the other way. Okay, so if it's less than 4, it doesn't meet less than 4, that means it's already greater or equal than 4. So there's no point of doing things like this. So it's 12. So it's going to be this condition. Although it doesn't throw any error message, but there's just no point. It can just be age less than 18. Understand? Just like here, you don't need to write like greater or equal than 18, less than 65, greater than 65, less or blah blah blah. So but usually the condition you want to be exclusive, so you don't want to like have multiple conditions in there. Understand? So less than something, like something. Just like at the end of the semester, I'm trying to give you a letter grade, right? If it is less than 60, you fail. If it is less than 80, you get a C. If it is less, no less, it's like greater than 80, you get a B, B minus, B plus, something like that. So this is how we can have a hierarchy. You have examples in the lab actually to practice this. So make sure you do that. If, else if, you can have multiple else if, but you can only have one else. So you will see here, right? There's no else statements. You don't have to have an else statement. I can do that. Else something, then price equals 0. What do you think? Is this one going to be executed? Oh, maybe I can do this. Price equal to 1,000. Will that ever work? Yes or no? So think about it for a minute. If S equals something less than 4, less than 18, less than 65, and then greater than 65. Is there anything else outside this scope? Outside the age range in here that you already checked? Is somebody either less than 65 or greater than 65? Is there some other age that like somewhere in between or like outside the numbers? No, right? It's going to be either and 4. So this condition has covered all of them. This portion will never be executed. Again, if it's just a number. But how about this? What do you think? Is age less than 4? I don't know. I actually if I have to guess, I don't know the result, because sometimes Python is doing things like very weird. So here, why actually this is a string, it's not a number. So when you try to compare, it might be comparing the ASCII code. So let me see here. It doesn't tell you. You cannot compare because this is a string, it's not a number. Okay, so it doesn't allow you to compare if this number and number, or you can compare number to number, or you can compare string to string. So again, this portion doesn't get executed. So you will never get there. No matter what input you provide, it doesn't go there. So I can maybe 101. So somebody is 100 and 101 years old, right? What's the price? How much? 20, yeah, because it's greater than 65. Okay. Or I can do this, right? If this like here less than 100, okay, the price is going to be 20. Else the price is going to be negative 10. Okay, what does this mean? So that means, okay, you're going to check the conditions. If less than 100, you get 20. If it is 101 or greater than 100, I'm going to give you a bonus. Okay, I only use $10. Okay, so in this case, you're going to get negative 10. So revise and then just to get a sense of like what this is doing. So if, else if, and then else. Again, you can also have multiple conditions, right? If something in something, something in something, something in something. So indentation, conditional statements, and checking the list, and these are all very, very important. So they're pretty much very similar. So if you're trying to check an item in a list, it's for something in something. If something equal to something, or if something equal to something else, then you can execute a bunch of conditions or statements just to do something. And you can have multiple lists. So when you're doing the looping, I can loop through multiple lists. So here we have 2 lists, and you can check the items in a list and then do something to another list. So for example, I have 2 lists, and when I'm doing the grading, right, I can say once I finish the grading, I move this one to another list. So you can have multiple lists together just to combine things together so that you can do something specifically to a list, and then modify the list. You can get an item from this and then push to another one. I think let's go back to notebook number 4. So that one has more information about how you can deal with the list, how you can do the slicing, how you can get something, how you can replace a specific number, or make some corrections if needed. So let me go back to here, working with the list. And I think we already covered some of those. So I have a list for something in something, basically just looping through the list. And is it run, or is still running? Alright, so you're also going to have some exercise in lab 4 showing you how to do that. So this is a list, and then for each item in the list, I want to do a title case. As I mentioned earlier, this name doesn't matter. It's a temporary something. So I can say M, but you need to do the same thing here, M, okay? As long as you use the same one, it's going to work just fine, because it's just basically a placeholder. Basically it's looping through the items. So once I execute this one, right now if I type M here, why M is like Carolina? Huh? Why is Carolina here? Understand the logic here. So this is a list, it's looping through the list, and then so M each time is going to be changed to the value of this item. So when it's looping the first time, M is equal to this one, and the second time is equal to this one, and then the last time is going to equal to last one. So that variable is still in the memory. So when it's trying to print out the variable, it's going to grab the value that the last time it was assigned. Understand? So right now, for example, if I change this one to here, I can say, oh, Joe, okay, run this one again, and now if I print out M, what's the value? Joe, right? So again, if you have no idea, let me show you here. Come back to this one, print, and then last time here print M, okay? So again, you can loop through that. You can each time. This is where the debugging is so powerful because it can show you how Python is actually executing the stuff. So make sure that if you're a beginner, try to utilize this one. So again, I'm going to start debugging, and I put a breakpoint at the beginning. So it's going to run, and then okay, on the left side here, try to pay attention. This shows you how Python create variables and also put that one in the memory. So right now I'm stopping the first one. I'm going to step through and pay attention to the left side. See how it is changing. You see here, magicians, variables, right? So we create a list of items with 4 items in that. And when you're executing, this is where things get into the memory, okay? So next one, pay attention here. We have a for loop, right? We're going to get into the for loop. So the first one, you see M. Do you see the M here on the left side? At least. And then it's going to print out here. So the printout will not come here. The printout message will at the bottom here at the terminal. So if I execute this one, pay attention. You see, it's done the first one, and you see how Python jumps back to the for loop. See that? So now I'm going to execute the next one. So pay attention here. M, this is the first item, right? So if I run this one again, you see it's changed to David, and then it's moved to the next one. It's going to print out the next one. See that? And done. And I'm going to move to the next one. You see M is keep updating it. So M is just a temporary variable each time being replaced with the value in that list. So now if I move again, see Carolina, and then you see the cursor move back and forth, right? So although Python is executing from the beginning to the end, but it doesn't mean that it's going to execute line by line. Sometimes it will go back, especially if you have a for loop, it's going to go back to the previous one. And so now the last one here, take a look. This is the last variable. It's all still in the memory. It's not clear yet. So that's why you can print out the M in here. And if I replace this one, I print out M, it's going to print out Joe here. Okay. So maybe let me do this. DL M. And can you do this? Can you print out M? What's the value of M here? Or would that even work? So what does this mean? I'm looping through that, and every time when I finish, I delete the variable. Okay, you see now it doesn't work. Why? Because you delete the variable, it's gone from the memory. You cannot call it. Okay, it's a temporary variable. So the reason for that is even with the last one equal to Joe, and then I already deleted that. You cannot use it again because it's gone from the memory. Make sense? So make sure that you utilize the debugging capabilities, especially for looping, conditional statements, or you have complicated script. Sometimes you have no idea why are you getting the result, why this is not what you expected. You debugging, you can see all the variable and see how the variable actually changing when you're executing each line. So everything somehow you're writing or executing have something in the memory. If it's in there, you can check it. You can see the result, and you can inspecting the outcome. Okay, so similar in here, you can run this one if you want to, right? So those are where you can looping through the list, and you can do something in the list, right? So magicians, and then for each one, I'm going to do something. And as I mentioned earlier, whether it's indenting or not, it's going to make a huge difference. If something is outside the indentation, that means it's going to belong to the script. So it's a top level, and you can say the second level and the third level. So here, I can like do this one, and then I can say if magicians equal to this one, I can print out an additional one. Alright, so right now, just looking at this line, don't execute it. Can you tell me how many lines of code this code block is going to generate it? How many lines in total you're going to see? The one get the correct answer get 1 extra credit for your final letter grade. Give me the result in 10 seconds.
8.
Can somebody tell me?
8.
8? Is it 8? Okay, Tracy, I think you get 1 extra credit at the semester. 1, 2, 3, 4, 5, 6, 7, 8. Okay, you're right. So the reason for that is like within a code block, every time it's executing, you're going to get 2 lines. So for every item you get 2 lines, and then so you have 3 items, you're going to get a total of 6, and so plus these conditions, and you're going to get another one because there's 1 Carolina in here, and so the last one is going to execute it always. So this is going to get 8, but let me change the condition. How many? How many lines of code you're gonna get? Okay, 5 seconds. How many? Thumbs up. How many lines? Give you another chance. It should be 10 lines. Right? So think about here. Each one you have 3 items. Each time you're going to execute these 2 lines, you're going to print out whatever. And then magician not equal to car, right? None of them is equal to car. So this line is going to execute it for all of them. So basically you're going to 3 lines for each item. So 9 lines and then plus the last one. So you're going to get basically 10 lines of text in here. 1, 2, 3, 1, 2, 3, 1, 2, 3, and then the last one. Okay. So this is where you can understand. If you understand, I don't need to see it. I know what the result is going to be. So you should try to get to that level. Just reading the code, imagine your mind, just looping through, and then can quickly figure out what the result would be without having to execute the code. So right now your brain, you need to think like a computer. Your mind need to be able to actually to read the code, run the code. Assume that there's a Python in your mind, just writing, looping through that. So yeah, if you get to that level, then you'll be much better. So that means you can really read and write. Also, make sure that just like I mentioned earlier, you need to have indentation. If you have something have a colon, the next you must have a line that's indented. So right, for this one it doesn't work. But if you do it right now, for example, you're writing a loop, and you have no idea, right, what I'm going to do inside the loop. For example, I'm going to ask you, each of you, to do something, but I haven't figured out like what I'm going to ask you to do. But I know I'm going to do something in there. So for me, I can just write a pass. Okay, a pass is a keyword that you're going to pass it. In that way, you don't have an error. So look at here. If I run this one, what result are you going to get? What do you think? How many lines of text you're going to print it out here in this case? How many lines? 1, 2, 3, 4, 5, 6. 2? Are you sure? It should be 1. So why? Think about here. I'm going to do the looping. I did nothing to the looping, and then you're just going to get here. And so this variable is going to grab the last value that you need to loop the last value. So this y is just going to get here. So pass, because I don't do anything in there. So just one line of code will be printed out. And indent, right? Again, make sure you indent. And just like in here, if you change this one, how many lines of code are going to print out? Everything is indented. So you have 3 items. You're going to print it out 2 lines of code for each item. So you're going to get a total of 6. But if I move this one outside, that means right now you only print out 1 line for each item, and then at the end you print out another line. So you're going to be 4 lines of code. Okay. Indentation, and then okay, don't indent unnecessary. Okay. So this works. This works as well. This doesn't work. Okay, you cannot indent unless you have another colon at the beginning, colon above. If there's another colons, right now this Visual Studio Code is pretty intelligent, so it can tell you what's wrong, but you have to understand when you should indent the line or when you should not do that. So make a colon. The next one we introduce is range. So this is also very frequently used function. So range means to create a sequence. Okay, so for value in range, let me show you this one here. Just to the range function, and so the range function, you can have the start and stop, and also the step. So here, range 1 to 5. It's going to create a sequence of numbers starting from 1 all the way to 5. But keep in mind, this is also varies depending on the language. So 1 to 5, it's going to create 1, 2, 3, 4. It doesn't include 5. Okay, so don't be. It only shows you like this. So this is basically a function. It's only show the result. But if I show you this one here, you understand. 1, 2, 3, 4, 5. So start, stop, and the step. Stop means it's going to be less than 1. So even if you have a range 1 to 5, it's only going to generate a number from 1 to 4. So if you really want to 1 to 5, you have to use like range 1 to 6. So in this way, it can generate the number from 1 to 5. Okay. So the stop criteria, that means if it is less than, then it stops. It is greater equal than, greater equal than, it stops. So make sure that you understand the logic here. And look at this one here, range. Oh, you can convert a range to a list. So this is where you can print out the number. So what you need, for example, right now you want to see what's inside. If you execute this one, it doesn't tell you the content. So if you really want to convert it, you can just type list and then parentheses. So this is going to convert this one to a list so that you can see the content. So a range is basically just a function. It doesn't show you the content. If you want to, just put this one and then you should be able to see that. If you want, for example, odd number, even number, this is how you can generate, right? So a range function, start, stop, and then the step function means each time you're going to increase that number, the next number, by adding this number to that. So here, right, we're starting with 2, and this is the stopping criteria. This is the step, means each time I'm adding this number to the previous one. So 2 plus 2 equal to 4, right? 4 plus 2 equal to 6, 8, 10, and 10. If you plus 2, it become 12. 12 is already greater than this one, so it stops. Understand? So right now, just a simple question. How do I generate the even numbers smaller than 100? Oh, let me see. I want to generate the numbers from all the even numbers from 2 to 100, okay, inclusive. So 2, 4, 6, 8 until 100. What should I be doing here? So what should I change in here? 11 to 101. Okay, good. See? So can I do like 100? Will the result be the same? What's the difference? Yeah, it doesn't include 100 because when you have 2 and 98, 98 plus 2 is 100. 100 is already greater or equal than. So your last number cannot be greater or equal than this one. So this is the stopping criteria. If you really want it, you will need to have increase 1 at least, or maybe, yeah, at least increase 1, but you cannot. For have 103, for example, it's going to have 102 in there because 102 is smaller than this one, right? So this is how you can generate this kind of sequence. Make sure that you practice. This is also very commonly used if you're trying to generate a sequence, right? Let me ask the other way. How can I generate the odd numbers from 1 to 99? 1 to 99. What should I be changing here? 1 to 99. So you'll be, what's the start? 1, comma, 100, comma, 2, right? So 1 to 99. Can I change this 1 to 0? Is it going to be odd number, even number? If it changes to 0, then it means what would this be like? What this line of code is doing? Yeah, what the number look like, right? 2 to 98, right? So it's basically generating the even numbers, right? Starting from 0 and then add 2, add 2, add 2, add 2 until you get to the end. So this is how you can do this one. And for example, you can have a square. Let's see, right? I'm generating number from 1 to 10, and I'm going to square. So in Python, the square is actually 2 stars square, and then the least you can append, right? Append something to an item, right? We already covered it in the last lecture. Append, insert, or something. So you can create an empty list, and at the end, I just print out all the results. So here, look at this one, right? 1 to 10, and then you just square, get all the numbers. So it will be 2, 3, 4, 5, 6, all the way to 10, right? You can also like 2 star basically exponential. So I can also have exponential to the 3, right? You see the number, right? Or I can have like 10. Oh, this is going to be huge. Also, you can do some simple statistics. So in Python, there's mean, max, or sum. So you have a list, you can calculate the sum, right? Or the minimum, the maximum. How do I calculate the average? 1 to 1, this list, right? 1 to 9 and then 0. So the total sum is, what's the sum? 45. What's the average? How do you calculate the average? No, right? You plus all together divided by total number of count, like how many in there. So if you need to do that, you'll be like this. The sum divided by, so in Python, the function is called length. Length means like how many items in there. So if you actually this one, take a look, 4.5. So you can calculate the total sum and then calculate length. So Python doesn't have a mean function. So if you're trying to like do this, mean and then digit, it's not going to work, okay? There's no such function called mean. Also, there's no like average. I don't know why they would not do that, but to me, this is just like you have to two step, calculate the sum, divide it, and then you can get the mean. The last one here is so-called the least comprehension. So least comprehension is essentially looping through the items and then do something to take every item and then return the result as a list. So this one is essentially the same stuff as this one here, but it's a lot shorter. So least comprehension you can think about just like a shortcut. So you're looping 3 items and then do something to the items and then you return the item you append to the list. So if this is what you want, you can achieve this with just one line of code. So when Python is executing, it's executing the later part. So for something in this list, for every item, I'm going to do the square. And then outside you have the square brackets at the beginning and the end. So that means you are doing something to this and then you put into the list. Do the second item, put into the list. So the result will still be a list. So this is also, if you want to write something like concise and elegant source code, this comprehension is also will be useful. Okay, so the last part will be just list slicing. We are running out of time, but we quickly go through this next week. But you should be able to go through and test it and start doing lab 4. Again, if you have any questions, send email to the list, email list, and I will be able to help you out. Okay, practice, practice, practice. I'll see you next week. Okay. Oops. So looks like the recording might not work this time. So you see, it's frozen. So we'll be out of luck. And but since we have all the notebooks, so you should be fine. But sometimes software doesn't like work, and there's nothing I can do.
Sorry about my lab submission. I don't know what was going on with it.
Oh, I haven't checked. I haven't read yet, but I got your email. Yeah, thank you.
That's going to be one that CT.
Uh-huh.